Okay, if you want to go ahead and pause this question here, and that way you can read the whole question and look at it. Um, and this one, actually, the part of it was a bad deal on my part. But what the question is asking is list the following the following molecules in order of solubility in a polar substance such as water from greatest to least. Well, the way I told you to to look at this was to always look at all the different polar spots. So if we see here, we have sugar, and remember that we determine polar spots by the polarity of the bond. So all these OHs are polar spots. This oxygen right here would be a polar spot because it's bonded to carbons, and so it's got an electronegativity difference of greater than 1. The same thing happens down here with your aspirin. You've got some OH, you've got some O there, and so you get these polar bonds, and that's what you want to look for. So if you were to look at all the polar bonds, you'd find that sugar is going to be your most soluble substance in a polar substance such as water. Okay, it's got so many different polar spots on there that it makes it a very likely candidate. Aspirin is your next most soluble with the next most polar spots. Now on here, vitamin D and A were bad examples for both of you, so I let people put them interchangeably as 3 and 4. It's not necessarily the case, but I really did do that because I mean they're both fat soluble vitamins, so that was a bad example. I should have put ones that were maybe a little more or less soluble than the other. But if you can tell, all these other bonds minus this little bit of O right there, all this is nonpolar. Same with down here, all of this is nonpolar. So neither of these are very soluble at all in water. In fact, they're both not soluble in water due to the fact that they are so nonpolar. So hopefully that clarifies some questions for people. But that's what you want to look at. You want to look at those polar spots if you're looking for a substance, whether or not it's going to dissolve in a polar substance. Remember, that key phrase is like dissolves like. Polar dissolves polar. Nonpolar dissolves nonpolar. So that's what you look for when you determine a substance's solubility.